Hey guys, welcome to this video on the standard normal distribution, and in this case we're going to be talking about the Z distribution or Z distribution. So what does this mean? Well, every normal X distribution can be transformed into the standard normal distribution or Z distribution using the transformation here, where Z is equal to our value of X minus the mean divided by the standard deviation. What this means is that the standard deviation, that we're going to have a Z score given to us. So this standard normal distribution, or Z distribution, has a mean of 0, so the standard normal distribution, or Z distribution, as we've got here, has a mean of 0 and a standard deviation of 1. So we've got a mean being equal to 0 and a standard deviation equal to 1. And we could say that that is Z Alright. The probability density function for Z distribution, and I will get to the Z score bit in a moment. And this is for all values of Z between minus infinity and infinity. Alright, so what does this Z score mean? Well, what the Z score is the value that we get when we actually work out from our normal distribution our value minus the mean divided by the standard deviation. So this bit just here. So what this equals is our Z score. And this means that the score that we get is that we've got standard deviations that the value of X is from the mean. If it's a positive number, it means we're going to be above average or above the mean. If it's a negative number, it's below the mean. So what this means is, if we've got a Z score of, say, 1.84, that means X is going to be 1.84 standard deviations up to the right of the mean. So if I was to draw our normal distribution curve, and we have our mean here, remembering that we're using the Z distribution, so that means our mean here is going to be equal to 0. We're going to have 1, 2, down here it's going to be minus 1 and minus 2, and if we keep going off we'll have minus 3, and up this end we'll have plus 3. So that means that our Z score here would lie somewhere about here. If our Z score was less than 0, and let's look at another case, I'll write this down quickly. Let's look at a different case where our Z score is equal to minus 0.273. That means that X is 0.273 standard deviations to the left of the mean. So x is 0.273 to the left. So that means that we'd be looking that it's somewhere about here for minus 0.273. Let's look at a quick example of this, and I'll also show you how to work out the probabilities using z-scores and your calculators as well. So do make sure that you have got this box here written down, also these bits of information here as well. So pause the video, get those down, and then we'll continue. Alright, hopefully you've got that written down. So we've got a student here who has scored 73% in history. The class mean, in this case, was equal to 68%. The standard deviation was 10.2%. Mathematics was 66% the grade that they got, with the class mean being equal to 62%. I'm hoping you guys get better than this. And the standard deviation of 6.8%. Now, what we're going to do is compare these two and work out in which subject did this student perform better comparing with the rest of the class. And we're going to have to make an assumption here that the scores for both subjects were normally distributed. So that is that they follow that normal bell curve that we've all come to know and love. So let's look at the z-score for history. And I'm just going to call this z-score. Remember that our z-score is equal to our value of x, take our mean divided by our standard distribution. Alright, so our z-score for history, we've got 73% minus 68% divided by 10.2%. And that is going to be roughly equal to 0.490. Let's look at the mathematics. So we've got 66 minus 62 divided by 6.8, which is roughly equal to 0.588. So what this means is that in maths, her result, or the student's result, was 0.55 standard deviations above the mean. So this is standard above mean. And in history, it's the same thing, standard deviations above the mean. So the conclusion that we can make is that this student's result in mathematics was better compared to the class, even though the percentage was lower. So even though the percentage, we're looking at 73% in history versus 66% in mathematics, comparing their score with the rest of the class, this student did better in maths than what they did in history. Hopefully that's made a little bit of sense. if you need to get this example down, please do. I'm then going to show you how to do these on your calculator. So if you need to get this written down, get it written down, pause the video, and we'll see you in a moment. Alright, so these are the 3 examples that we're going to look through on the calculator. Again, to illustrate these, it's exactly the same as the last video, so go back, have a look at that, remembering that our mean, in this case, is 0. So our mean is 0, and our standard deviation is equal to 1. Alright, let's look at the calculator. I'm just going to talk through these 3 examples on the calculator, so we won't come back to this screen again. If you want to just jot these down, so you've got something to reference as I go through, please do. Alright, so let's look at what it's like on the calculator. So again, we're going to use normal CDF. So second dist r normal CDF. We're going to put in our lower bound. In this case was 0, clear that, negative 0.41, our upper was 0.67, our mean, because we're using z-scores, is 0, and our standard deviation, because we're using z-distribution, or looking at z-scores, is 1. Enter, enter, paste, and it should come up like that. Enter, and we get roughly 0.408. So that means that the score, or it's going to be roughly 0.408. Let's look at the next example, where we're going to be less than 1.5. So again, second dist r CDF. Our lower bound is going to be 1 minus 1 power 1099, and in this case we'll go 1.5. Enter, enter, because those stay the same, and paste that value in. Enter, we should get 0.933. And our final one, we wanted to know to be greater than 0.84, so we're going to 0.84. Our upper bound 1 by 10 to the power of 99. Enter, enter, paste, and we get 0.200. So that's all that I really wanted to talk through for this section on the standard normal distribution, or Z distribution. Hopefully that's made a little bit of sense. If you've got any questions, just ask. As always, thanks for watching, and we'll see you next time. Bye for now.